Okay, so here we go again. We are going to do another graph of a rational function. And again, these are the list of the things that you need to remember how to do. Okay, so just remember how to find the domain. That's the values that are exclusions of the denominator, where x cannot equal 0 in the denominator. Range, we look at the graph when we're done and decide from bottom to top. X-intercepts is the value of x when y equals 0, and it's an ordered pair. Y-intercepts is the value of y when x is 0, and it's also an ordered pair. Vertical asymptotes relate right back up to that domain. We're going to look at an example today where you're going to have the domain is going to be slightly different than the vertical asymptotes, so that'll be something good to look at today. And then the horizontal asymptotes. Again, you have to decide, looking at the degree of the numerator and the denominator. If they are equal to each other, then you use the a over b. If the degree of the denominator is greater than the numerator, then it's automatically y equals 0. Or the other type of asymptote you might have is a slant asymptote, where the denominator degree is less than the numerator, and then there'll be some synthetic division that you have to do with that. And we will actually do an example of that in class on tomorrow. So we haven't actually looked at a slant asymptote yet, but we will get to that. Here's the example from the first video. All right, so let's go ahead and look at this next problem. So we have x squared minus 9. So let's go ahead and look here. If we factor it, if we factor x squared minus 9, x squared minus 9 is a difference of squares, so I know that that's going to factor to x minus 3 and x plus 3. And then in the denominator, x squared minus 2x minus 3, they multiply together to be negative 3, add together to be negative 2. We are going to have x minus 3 and x plus 1. Again, this whole factoring process needs to become something that you're getting pretty good at, hopefully, over the course of the amount of times that we have done it. So our domain, remember, this is the only thing we find before we simplify. So our domain is that x can't be 3 and x can't be negative 1. Okay? So as we're thinking about how we would write that in terms of interval notation, I sometimes like to think of it on a number line, right? So negative 1 and negative 3. Here's negative 1, 0, 1, 2, 3. If it helps to think about it this way, we can't have a value here and we can't have a value here. However, everything else is fair game. So from negative infinity all the way to negative 1, that's fair game. So from negative infinity to negative 1. And we jump over negative 1, and then we have this part of the number line right here, which is from negative 1 to 3. And then if we jump over 3, because we can't include that, then we are over here at from 3 to positive infinity. Okay, so I sometimes think that it helps if you think about it on a number line. And when we get into nonlinear inequalities next week, this will actually be helpful to think about a number line. Again, we will come back and do the range after we have got all the other stuff figured out and we have it graphed. So now we're going to look at what we have now that we have our domain, and we are going to simplify. We can take out an x minus 3 on the top and an x minus, or excuse me, not an x on the top, yes, and an x minus 3 on the bottom. So all we are left with that we're going to deal with is x plus 3 over x plus 1. Okay, so after our finding the domain, use a simplified equation. That's what it says here. Our x-intercepts, remember, is our value of x when y equals 0. So if we have 0 equals x squared, actually, let me fix that, right? Because we're not using that whole equation anymore. We have x plus 3 over x plus 1. If we think about it as a proportion, if we do cross multiplying, 0 times that is going to be 0. 1 times x plus 3 is going to be x plus 3. So our x-intercept is at negative 3, and remember that that is an ordered pair. So our ordered pair is going to be negative 3, comma, 0. So we can plot that guy on our graph down here. So we're at negative 3, 0. Let's put him down here, 1, 2, 3. There's our negative 3, 0. Okay, our y-intercepts, again, is the value of y when x equals 0. So we're going to say y equals 0 plus 3 over 0 plus 1. It's coming from there. So that's going to be 3 over 1, which is just 3. So our ordered pair will be 0, 3. Okay, so let's highlight that there. So we're going to be at 0, 3. So come down here on our graph, and we're at 0, 3. Those are our two intercepts that we have. Our vertical asymptote, remember that's going to be after we've simplified. So after we've simplified the domain of x can't be 3, we took that out of the original problem when we simplified it. So the only vertical asymptote we are going to have is going to be at x equals negative 1. So we're going to make a vertical asymptote at x equals negative 1. So we're going to be here and here, like that. Okay. The horizontal asymptote. Okay, so how do we find that horizontal asymptote? It has the same degree, which means we are going to use y equals a over b. And our lead coefficient of the top is 1. Lead coefficient at the bottom is also 1, so we'd have y equals 1. So our horizontal asymptote is going to be at y equals 1. So let's go ahead and plot that guy in there. We're going to be at y equals 1, which is right here. Okay, so far so good. Slant asymptote, well, since we have a horizontal asymptote over here, that means that the values of the degrees were the same, which means there's not a slant asymptote, so that's going to be a none. Okay, the holes, remember this is where the values that we simplified out. So we simplified out x minus 3 out at the top and the bottom, remember? Which means our hole is going to be at x equals 3. So when we go to graph here at x equals 3, we are going to put a hole. So if you need to look at a graphing calculator or something to help you to know where the branches are, however, these x and y intercepts should probably help us. But if you need to use your graphing calculator, feel free. And we are going to use a different color here. Go like this, and we hit our x-intercept, and then we hit our y-intercept here. And then we can't forget that we have a hole, remember, at 3, at positive 3. Yep, at positive 3. So at positive 3, 1, 2, 3, on our graph, we're going to have a hole, and technically I should erase that inside of that. And then that doesn't really want to erase, but there, at 1, 2, there's a hole right there where the graph actually skips over, and the blue didn't want to erase for some reason there. And then the last thing we can't forget is to go back up and find our range. And our range, as we read it from the bottom to the top, is from negative infinity. It comes up and it stops at 1, and then it goes on to positive infinity, which means we are going to have a range up here. There we go, a range from negative infinity to 1, and jump over 1, because that's an asymptote, and we go from 1 to positive infinity. So there's all of the things we need in our graph that goes along with it.